Hello and welcome to Game Dev Guide. In the last episode, we started building a localization system for text. In this video, we're going to take a look at extending the system further so that we can write, edit, update, and search through our data inside of Unity, so we can easily work with it in our pipeline without having to keep swapping to another program or tool to make and view entries. As you can see here, I've got this nice little tool that pops up in any instance of a localized text component and allows me to search through for repeat entries and easily find the corresponding key. So the first thing we need to do is extend our CSV reader system, as we want to be able to add and remove values from our file. Let's create our first method to add a new line to the file. We'll call this add and we'll pass in our key and value to add. We'll then write a string formatted to the style of each line. We're leaving the gap here for our French version so we don't have to force entering all of the translations when creating a key and value. In a production, it's most likely that you'll design the values for the language you're working in, then you'd export the CSV into something like Excel for a translation team to work with. So we're leaving in the extra commas here to add the French or other languages in manually later. Then we'll force the asset database to refresh. It just makes sure that the editor refreshes the text asset properly after we've added the text. Next, we write the remove function. We pass in the key we want to remove, and similar to our reader function, we'll split our lines up. We'll make a string array to hold our keys. Then we'll get the keys from each line. And we'll iterate through our keys to see if the requested key matches. If it does, we'll set that as our index. And if the index is a match, we'll create a new array for the lines, but leave out the index we want to remove. Then we join them all back up again and write that into the text asset. Finally, we'll write a method to edit an entry, which combines both our remove and add features. We'll remove the key from the list, and then add the edited version in as a new entry. We wrap these classes in an if and if directive to make sure they're not compiled in a build and only the reading works at runtime. Back in our system, we're going to write 3 static methods. First though, we're going to make a quick change and move our CSV loader declaration out of the init function and store it as a static variable. This is so that our add, remove and replace functions we're about to write can all work with it. We'll also move our dictionary assignments to its own method called update dictionaries. For our add function, we'll check if the string being passed contains any quotation marks and reformat them. Then we'll check if the CSV loader is loaded and add the value to our CSV. We do pretty much the same thing with the replace function, just calling the edit CSV function instead. And finally, we write a remove function. And that's our system extended. Right, so we want to build some handy editors for this system now, and there's a few things we want to do that will make working with the system quick and easy. So let's go over the design. Ideally, we want to be able to add a value for a key if it doesn't already exist, or if it does, edit that value from our text localization component. It would be great to be able to see the value of a specific key we've assigned to our text without having to open up the localization sheet. We want to be able to look at a field in the inspector and preview the value of that field. On a similar note, it would be extremely useful to be able to search through for keys or values already in the sheet. So we don't need to spend time worrying about what that specific key was for that specific value, we can just search the word we're looking for and have the tool return its key to us. To achieve this, we're going to create a custom localized string with a unique property drawer. That way, we can refer to and work with these tools wherever else we may want to implement localized values. Additionally, by defining a variable as a localized string, we can easily see in code what's going to be changed, so there's visibility and readability bonuses too. So, let's create our localized string class. We're actually going to make it a struct instead of a class. This is mostly so that we're never dealing with pointers. We'll create a public string, which will be our key, and set that when the struct is declared. Then we'll get a public variable called value. When called, this will request the value from the localization system. And finally, we'll define an implicit operator, which will allow us to assign a new key to a localized string with ease. This isn't really necessary, but it's a useful thing to be able to do. Now we need to write the property drawer. As discussed earlier, we want our localized string to allow us to enter the key in the editor. We also want it to show us a value if there is one, and allow us to add a value if there isn't, as well as a handy way to search the entire range of keys and values. So we'll want to represent these in our drawer. To get started on our editor, let's create a new folder named Editor and create a new class called Localized String Drawer. In the script, we'll include the Unity editor namespace and will derive from the Property Drawer class. We'll also give this the custom Property Drawer attribute. We'll then create two private variables, a boolean called dropdown and a private float called height. We'll override the getPropertyHeight class. This will allow us to check if the dropdown is enabled, and if it is, we'll extend the height of our property in the editor so we'll have room to display the value. Adding about 25 to the height should be enough, otherwise we'll just return a height of 20. Then, when the GUI is drawn, we'll begin the property. We'll start by drawing the label and then adjusting the rect. We'll then create a rect for the foldout based on this. And we'll create a text field for the key. After the text field, we'll draw a search button. I've got a custom icon stored in my resources folder for this, which I'll add to my button. We'll also draw an add or edit button. And finally, we'll check if the drop-down button is active, and if it is, we'll draw a label with the value returned. Now, if we go back to our text localization component and swap it from a key to a localized string, when we look in the inspector, we'll see our custom property drawer. Now we just need to make the buttons functional. Okay, so let's create a new script in our editor folder called Text Localizer Editor. Here we're actually going to write two classes in one script. The first one will be our window for adding and editing, and the second one will be our search panel. So we'll call this one Text Localizer Edit Window, and we'll have it derived from Editor Window. We'll write a static open function and request a key to be passed in. We'll then create an instance of this window and show it as a utility window. We'll then create a public key and a public value string, and we'll go back and assign the key to the instance window. On our onGUI function, we'll simply create a text field for the key and create a word wrap text area to input the value. We'll then add a button which, when pressed, will add the key and value into our localization system if it doesn't exist. If it does exist, we'll edit the value instead. Then we'll set the minimum size of the window so that it always opens to a decent size. Finally, we'll create a new class in the same script called Text Localizer Search Window. In our open function, we'll get the mouse position and create a rect based on that position. We'll then show the window as a dropdown. We'll create a string as our value, and a vector2 for the vertical position of the window should there be multiple results we need to look through, as well as a local dictionary for the window to work with. When our search tool is enabled, we'll request the dictionary from the localization system. This is a static function in the system that we can add that just double checks the system is loaded, and if it is, returns the English dictionary of values and keys. So back in the editor window, we'll create a text field to be our search string and then assign it. We'll then write a method called getSearchResults, which, if we have a value, will start a scroll view and go through each key value pair in the dictionary to check if the key or value contains our search string. If it does, we'll create a button so we can remove it, with a warning dialog just to confirm any accidental clicks. I had to add this to protect myself from my own stupidity. I lost a lengthy piece of dialogue due to this confirmation not being there, and that day I learned some valuable user experience lessons. Anyway, if it is confirmed, we'll remove the element and update the dictionary we're using so it disappears from the list. And then we draw a text field for the key so we can easily select it to copy and paste into our property, as well as a label field for the value. If you want to take a step further, you could potentially add another button here for editing values returned in this list and opening the edit window we've just created. I plan on implementing that myself at some point in the future, but it hasn't become enough of a problem for me just yet. All we need to do now is call these windows when our buttons are pressed. And that should be it. If we go back into our project, we can open up, search, edit, and add values from any instance of our localized string property. And that's it for this guide. Hopefully you can see how useful this is, as it should now be super easy for anyone on your project to add, edit, view, and remove localized values from within Unity. If you've enjoyed this video, be sure to hit the like button and leave a comment. And of course, if you're interested in more game dev tips, tricks, and tutorials, be sure to subscribe. I'll see you next time. Thanks for watching.